Hello everyone, welcome to the number series topic. This video is brought to you by Learning Made Easy team, a team of IIM grads in association with our e-learning partner GTCUBE, Get to the Top. If you are watching this video in our YouTube channel, do check out our full-length courses available for free at gtcube.com/store, where you'll get to see these videos as part of courses and also get to practice hundreds of questions on these topics so that you can strengthen your understanding. So let's get started. First, let's try to understand what we mean by the number series topic. So we see this set of standard questions asked like find the next term of the given series. So we are basically given a series. We have to understand the relationship between the terms, the logical relationship that would be existing between them, based on which we have to guess the next term of the series. Now that's a standard type of question that you would see. Sometimes we'll also see questions asking like find the wrong term in the given series. So they'll give you the entire series, and you have to figure out which of these terms is actually, which one of these terms is actually the wrong term according to the relationship that exists between all these terms. So let's get to understand, standard logical premises that would be used are the patterns that are generally observed in these questions, so that you can tune your brain to think in that direction and solve the questions that are being asked in the exams. So the very standard pattern, first type would be, you'll have a series where you're basically adding or subtracting, multiplying or dividing a constant. So let's look at this part, 1, 3, 5, 7, 9. What's the difference between 1 and 3? 2, right? If I add 2 to 1, I'll get 3. If I add 2 to 3, I'll get 5. If I add 2 to 5, I'll get 7. If I add 2 to 7, I'll get 9. So you see, this is the pattern, right? So what would be my next term? Again, I have to add 2, that will be 11. 1, 3, 5, 7, 9. So I am adding a constant number to the previous term to get the next term. 2 is added to 1, 2 is again added to 3 to get 5, 2 is added to 5 to get 7, so on. So let's look at the other example, 20, 17, 14, 11, 8. So 20, 17, I have to subtract 3 to get 17, right? If I subtract 3 from 20, I'll get 17. Similarly, if I subtract 3 from 17, I'll land up with 14. If I subtract 3 from 14, I'll get 11. If I subtract 3 from 11, I'll get 8. So obviously the next would be 8 minus 3, that is 5. You see, I am subtracting a constant number to build this series. The third example, 2, 4, 6, 8, 16, 32. You see this, 2 2s are 4. Okay. So again here I am, let me show this. So actually it should not have 6. So let's ignore 6. So it's 2 into 2 is 4. 4 2s are 8. 8 2s are 16. 16 2s are 32, right? It is just multiplying with a constant number. So if we have 6, that's going to spoil the pattern and we would not be able to establish a relationship. So what will be my next term? 64. That is 32 into 2 is 64. The last example, 243, 81, 27, 9, 3. 243, 81, 27, 9 and 3. If I divide 243 by 3, I'll get 81. If I divide 81 by 3, I'll get 27. If I divide 27 by 3, I'll get 9. If I divide 9 by 3, I'll get 3. So what would be my next term? That would be basically 1. If I divide 3 by 3, I'll get 1. That would be my next term. Right? So if you see these 4 examples, I'm adding a constant number 2, 2, 2 to build the series, or I'm subtracting 3, 3, 3 from each term to get the next term, or I am multiplying with a constant number 2, 2, 2, or I am dividing with 3, 3, that's a constant number, right? So this is one pattern that you would see in the series, that I am actually adding, subtracting, multiplying or dividing using a constant. The next type is basically doing the same operations, but you don't have a constant number, but rather I'll see a pattern even in what I'm adding or subtracting, dividing or multiplying. Let's look at this example to clarify this. 1, 3, 6, 10 and 15. What's the difference between 1 and 3? I have to add 2 to get 3. 3 and 6 I have to add 3, 6 and 10 I have to add 4, I have to add 5 to 10 to get 15. You see, in this example I was only adding 2 to the previous term to get the next term. Here I am adding 2 in the first number, for the first number, next I am adding 3, next I am adding 4, next I am adding 5. I see a pattern for 2, 3, 4, 5, right? That is basically they are increasing by 1 plus 1. So what will be my next one? I have to increase now by plus 6. So that will make my next term 15 plus 6, 21. Now that's the difference between this. I'm adding a constant number in this example, but here I am not adding a constant number to the previous term. Rather, these terms which are being added are also actually following a pattern, which is 2, 3, 4, 5 and 6. Right? So that is the slight difference that you will see. Let's look at another example, 20, 18, 15, 11, 6. 18, 15, 11, 6. I have to subtract 2 from 20, 3, 4 and 5. So technically I should be subtracting 6, right? Minus 2, minus 3, minus 4, minus 5 and minus 6. So 6 minus 6 would be 0 is my next term. So that's how I will see the series. You see again the difference, minus 3, here I have a constant number which is being subtracted, but here I am seeing different numbers that are being subtracted for each term, but they are also following a pattern, 2, 3, 4, 5 and 6. Let's look at this, 2, 6, 2, 6, 24, 120 and 720. 2 into 3 is 6, 6 into 4 is 24, 24 into 5 is 120, 120 into 6 is 720. You see I am multiplying with some numbers, but they are not a fixed number. Into 3, into 4, into 5, into 6. Obviously the next term should be multiplied by 7. 720 multiplied by 7 would give me the next term, that is 5040. Right? Which is slightly different from what we have seen here. I am always multiplied with 2, 2, 2 and 2 to get the next term in this series. The final example, 120, 60, 25, so on. So 120, 60, if I divide by 2, I'll get 120 by 2 is 60. 60 divided by 3 will give me 20. 20 divided by 4 will give me 5. So technically I should divide the next term by 5. So 5 divided by 5, 1 would be my next term of the series. Right? So here again the difference is, in the earlier example I was having the constant number being divided, whereas in this case we are seeing a different series 2, 3, 4 and 5. I am using a different number to divide for each term. Another type, the pattern I would rather call is seeing perfect squares, cubes and higher powers. For example, 1, 4, 9, 16, 25, 1 square, 2 square, 3 square, 4 square and 5 square. Right, these are 1, 4, 9, 16 and 25. So the next term would basically be 6 square, that is 36. So that's as simple as it can get. Now another example is 0, 1, 8, 27, 64, 125. This is 0 cube, this is 1 cube, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 124. So the next would be 6 cube, that is 216. So we will be able to understand these series might be having higher power or something if we know the perfect squares and cubes generally. Right? If you are someone who has this good understanding of 4 square is 16, 4 cube is 64, 5 cube is 125, if you remember these numbers, it would be helpful for us to actually make a guess that okay, this series might have something to do with the squares, cubes and maybe higher powers. This series is 116, 81, 256. That is 1 square, 1 power 4, 2 power 4 is 16, 3 power 4 is 81, 4 power 4 is 256. So next one should be 5 power 4, that should be 625. Right? So again, slightly similar to what we have seen in the earlier patterns. Instead of adding a fixed number or changing number, but we rather add it to the perfect squares or cubes. That is basically the mix of this and what we have seen in this, right? This or this. So there's the mix of both. Here I was adding 2 to 1, 3, etc. Right? Rather I can also add to squares a 2, a 2, or maybe some other number. So let me show with examples to make it clear. So you see 2, 5, 10, 17 and 26. So this one is basically 1 square plus 1. This one is 2 square plus 1. This one is 3 square plus 1. This one is 4 square plus 1. This one is 5 square plus 1. Right? I've just added a constant number 1 to the perfect square series to get this new series 2, 5, 10, 17, 26. So what will be my next term? That should be 6 square plus 1, that is 36 plus 1, 37. I can multiply into 1, or I can also do 1 square into 2, 1, 2 square into 2, 3 square into 2, and make series. Or I can do 1 square into 2 plus 1, 2 square into 2 plus 1, all these things. So there is no end to what we can create. So just keep the possibilities in mind so that you can actually think of the right relationship. Another example, 2, 16, 54, 128, 250. 2, 16, 54, 128, 250. Right? I see here 2, next I see 16, and next I see 54. What is this? I would say 1 plus 1, it's 1 square, 1 cube. I'll see this. This one is something like 4 square is what I'm seeing, but I would rather try to see if I can add something, right? Let's say 3 square plus 7, or it could be 2 cube plus 8. I don't know yet. Let's look at 54. 54, 7 square 49 plus 5 is one possibility, right? Or is there anything else that I can look at? 27 into 2, yeah, right? This is also another possibility, right? 3 cube into 2. So here also I can have something like 1 cube into 2. Here also I can have 2 cube into 2. 8 2s are 16. 3 cube into 2. And this one is 4 cube into 2. That's 64 into 2 is 128. And this one is 5 cube into 2. That's 125 into 2 is 250. So automatically my next term would be also seeing the same pattern, 6 cube into 2. So 6 cube is 216 into 2 is 432. So the answer would be 432 for this series. Let's look at another example. So here I am actually multiplying the cubes with a constant number 2. 1 cube into 2, 2 cube into 2, 3 cube into 2, 4 cube into 2, and so on. Like here I was adding 1 square plus 1, 2 square plus 1, 3 square plus 1, and so on. Let's look at this example. 4, 20, 86 and 262. So here again I see something like 1 plus 3 or 1 square, 1 cube, etc., right? So again here I would see 2 power 4 is 16 plus 4, right? Here I would say 3 power 4 is 81 plus 5 is 86. 4 power 4 is 256 plus 6. So what is the pattern I am seeing? I can say 1 power 4 plus 3 here also. 1 power 4 plus 3, 2 power 4 plus 4, 3 power 4 plus 5, 4 power 4 plus 6. So 1 power 4, 2 power 4, 3 power 4, 5 power 4, 4 power 4, and then what am I adding? I am actually adding a series. It's 3, next I am adding 4, next I am adding 5, next I am adding 6. Unlike here I was only adding 1, 1, 1 and 1. Here I am actually adding a series of numbers which are following a pattern like 3, 4, 5, 6. So the next term would be 5 power 4 plus 7. Right, so 5 power 4 is 625 plus 7 is 632 would be the answer for the next term. Right, I know these are complex in some ways. So the best way to get used to these things is practice. Once you practice, different types of questions, you will get to know the different patterns that are generally used in these questions, and that is the best way to actually get used to and find an easier way to solve these problems. There is no easy technique to say, okay, if you see a number like this, go with this. So the whole idea of us discussing these standard patterns is for us to tune our mind to think, okay, these are the possible ways the questions could get framed. So should I check this? Okay, let me check this. Okay, it's not working out. Let me check another way. That's why you'll build the different ways to check and find out the logical relationship. So other patterns would be using the previous terms, series of previous terms. If you see this earlier example 1, 3, 5, 7, I'm adding 2 to 1 to get 3, 2 to 3 to get 5 and so on. So I'm still using previous terms, but let me show this example. 3, 4, 7, 11. If I find the difference, it's 2, this is 1, this is 3, this is 4. I'm not seeing any pattern 2, 1, 3, 4. It's all a bit complicated, right? What is the other thing that you should check is this 1, 3, 4, 7, 11. What is 1 plus 3? Is 4. What is 4 plus 3? Is 7. What is 4 plus 7? Is 11. You see this? So the two terms are added to find the next term. So what should be my next term? 11 plus 7. That's 18 would be my next term in this series. Right? Sometimes it could be 3 terms that are being added, or it could be subtraction of 2 terms. You have to be very careful on our multiplication. Let's see this example. 2, 3, 6, 18, 108. I'll just show the difference between them. 1, 3, 12, right? And this would be up 90. I don't see any pattern, right? So let me show this in this way. When I multiply 2 and 3, what would I get? 2 into 3 is 6. When I multiply 6 into 3, I'll get 18. If I multiply 18 into 6, that's 108. Right? So the previous terms, 2 terms are multiplied to give me the next term. So what would be my next term? That's basically 18 into 108. Right? Whatever I'll get, that would be the answer for the next term. So that is basically using the previous terms to generate the next term, series of terms like this. That's another pattern that could be used to create a series. Then we also have intermingled series. Basically you'll see 2 series or 3 series clubbed, and you generally see the alternate terms being part of a series. Like if you see this example, 2, 6, 10, 14 would be one series, 3, 9, 27 would be another series. Otherwise you won't make any sense out of 2, 3, 6, 9, 10, 27. Right? This is 1, this is 3, this is 3, this is 1, this is 17. I don't see any sensible pattern here, even if I try squares, cubes and all of that. But if I split this like this, there is series 1, which is basically 2. I'm skipping 3, I use the next term 6, I'll skip 9, I'll use 10, then 14, then 18 and so on. And there's another series which is 3, 9, 27, 81 and so on. Right? So here I see this, right? 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14, 14 plus 4 is 18. So the next term would be 18 plus 4, 22. Here 3 3s are 9, 9 3s are 27, 27 3s are 81, and the next term would also be multiplied by 3, that would be 243. So after 18, I should have 243 and then 22, right? That will be the continuation. So the basic thing is that I have to basically split into multiple series. It would generally be seen in the alternate terms. This 6, 10, this another series will be 3, 9, 27, and then you'll see some logic that we have discussed till now, based on which you can build the next terms of those series, and then you have to combine this series. So see, what is the last term here? 18, which is part of the first series. So obviously the next term would be part of the second series. After 81, whichever the term that will come would be the next term. After 243, I'll have 22 again. Now that's how this intermingled series works. So these are some standard patterns that would generally help us to get a, use these to actually solve the questions. Standard patterns which are most probably used in most of the questions. So we'll also discuss about one general technique that helps us in most cases, right? So let me show this. Find the next term of the given series: 6, 24, 60 and 120. So you see, I know that 6 into 1 is 6. 6 into 4 is 24, right? 6 into 10 is 60 and 6 into 20 is 120. So the ones which are multiplied by 6 are changing, right? I see 1 here, 4 here, 10 here, 20 here, right? That is what the pattern that we are seeing here. So what would be my next term? Potentially the next term that could come out of this. Now I am actually trying to get a relationship for this 1, 4, 10 and 20. So let me see, 1 and 4, 3, 4 and 10 is 6, 10 and 20 is 10. You see this? Then what is the difference between this? 3 and 6 have a difference of 3, 6 and 10 has a 4. So the next term should be 15, the difference of 5. So that what will be the term? 1, 4, 10, 25 and then it should be 35. So I should multiply 6 into 35 to get 210 as my next term. So here I am actually, let me repeat this again to just clarify this. 1, 4, 10 and 20 I know are the multiples that are used for 6, 24, 6 and 120. So I need to figure out what should be the next term in this logic so that I can multiply with 6 to get the actual term, right? If I know that's 35, 6 into 35 would be my next term for this series. 6 into 1, 6 into 4, 6 into 10, 6 into 20. So 6 into 35 would give me 210. So how did I calculate 35? So I am trying to establish a relationship between 1, 4, 10 and 20. So I'll first see if what am I adding here, right? 1 plus 3, 4 plus 6, 10 plus 10 is 20. So again, I don't see any straight pattern between 3, 6 and 10. But I'll see this, right? What is the difference between 3 and 6? 3. 6 and 10 is 4. 10 and automatically I'll expect 3, 4. And now I see a pattern 3, 4 and it should be 5. So it should be 15. So now 20 plus 15 should be 35. So here I am actually going 2 steps below to actually solve this, right? So this is generally an expected thing. In harder or difficult problems, you will see where we have to go a couple of levels below to figure out the real pattern. You won't straight away see 1 plus 3, 4 plus 3, 10 plus 3, 20 plus 3 or anything like that. You will see a behavior where I have to figure out by going a couple of steps below to see if there is any relationship. So the same question could be also solved in slightly different way, which is 6, 24, 60 and 120. I'll just try to find the difference between this 18, this is 36 and this is 60, right? Still I don't see a relationship between this 18, 36, 60, 18 plus 18, 18 into 2, 18, 3 that it should be 54. I'm not seeing any pattern. Let me see the difference between this. This is 18 and this is 24, right? So here I see 18, 24, so the difference could be 6. So 6, add 18 plus 6 is 24. So the next term should be also adding plus 6, that should be 30. That means it should be 90. 36 plus 24 is 60, 60 plus 30 is 90. So 120 plus 90 is 210, which is what I calculated here, right? So I am not using any other technique. I am just going on in this multiple levels to see where I can see a simple pattern so that I can use that pattern to solve the question. Right, let me show this example again. 2, 16, 54, 128 and 250. Right, if you remember this was basically 1 cube into 2, 2 cube into 2, 3 cube into 2, 27 to the 54, 4 cube into 2 and 5 cube into 2, which was something we discussed in the earlier example. So I can use this technique to solve even this. Let me show this. 2, 16, 54, 128 and 250. What is the difference between this? 14. This is 38. Right, and this would be 74. And this is 122. What is the difference between this? Now I am not seeing any pattern between 14, 38, 74, 122. So I'll again go down a step below. 14, 38 is 24. And this one is 36. And this one is 48. Right? So again, I can understand if you are quick, you will understand 6 4s are 6 6 are 6 8s are. But let me again go ahead and do the difference again. This is 12. This is also 12. Now I am seeing a fixed pattern, right? 12, 12. So automatically the next term should also be sum of 12 and 48. That should be 60. So that means this should be 122 plus 60 is 182. So I need to add 182 to 250 to get my next term. That is 250 plus 182 is 432. So what is the number I calculated here? 5 cube into 2. The next term would be 6 cube into 2. That is 216 into 2 is 432. You see, I got the same answer. So the technique I used is different. If I could have figured this out, I would have answered this in maybe less than a minute. Here maybe I'll take 1 to 2 minutes depending on how quick I am with respect to the addition subtraction. But this technique will most probably give you answer for most number of questions. So personally I prefer this because you never know how quick you can get the actual logic used in the question. So if you use this technique, even though you might have to go a couple of layers below and see the real stage where you'll see the consistent relationship, but it will still give you the answer in most likely likelihood, which means the chance of answering is high, even though you might take a little bit more time. So it's up to you. You practice. If you are very clear with the standard patterns, you can really figure out the relationship faster. That might be still the better way, but this one is something that you can use as a last resort, or maybe as the first option itself if you are someone who is comfortable spending time, as long as you get the right answer. So let's get started solving some sample problems. As we regularly suggest, pause the video, try this question on your own. Once you're done, we can check the solution, and if you can also follow our explanation if you could not solve it. Even if you could solve it, you get an idea of how to solve it, maybe in a different way if you have not used the same method. So find the wrong term of the given series. So here the question is, they have given this, I have to figure out which of these following terms are wrong. Right, so I see 120, 93, 86, 81 and 80. What is the difference between 120 and 93? I see 27. 93 and 86 is 7. This is 5 and this is 1. So I'm not seeing much of a pattern, right? Even if I go a level below, it's 4, this is 2 and this is 20. I'm not seeing any consistent thing here as well. So there is one of the terms that is basically disturbing this. So what I see is this, I see 27, I see 1. So whenever I see 27, immediately it sort of gives me vibes of 3 cube, 3 power 4, 3 power 2, 3 power 1, etc. Or maybe some multiples of 3s. So let me try this. Let me see, this is 1, this is 27. So technically I should have a 27. So if I have 3 and 9 here, right? 1 into 3, 3 into 3, 9 into 3 is 27. So 120 minus 27 gives me 93. 93 minus 9 gives me 84. 84 minus 3 gives me 81. 81 minus 1 gives me 80. So 120, 81, 93 and 80 are already part of the series. I only see 86 being the spoil sport here, because of which I could not find the relationship. So this was the pattern which is basically not being shown in this because of 86. So the correct term is 84 and the wrong term is 86 in this series. Right? So that's how we'll solve this. Let's look at the next one. Find the next term of the given series. So this is the series 12, 35, 47, 82 and 129. I need to find the next term. So again, I'll start off with the differences. 12, 23 is the difference. This is 12 and this is 35 and this would be 47. So here I don't see much of a pattern per se. 23, 12 is like I'm negative, I'm going minus, and then I'm going again plus 23 and again I'm going plus 12. So even if I subtract, I go ahead, I'll do like I get 34 and then 35 and things like this. It's not much of a pattern per se. So here maybe we might feel that let me try this. 34, 35 sort of gives us a sense that okay, let me try 36. I see 34, 35, 36. I mean 34, 35, the logical is 36. So 36 plus 12 is 48. Right? So 48, 12 plus 36 is 48. 47 plus 48 is 95. If I add 95 to 129, I'll get something. But here there's a problem with this logic because I'm not seeing a consistent thing here, right? Minus 11, 23, 12. So I just got two consecutive lucky numbers. I don't see this logic being, give me confident answer. What could also be, maybe you go ahead and do it, you'll get 129 plus 95 is 234. Right? You'll see the options if you see the options. Most likely you might not see the option depending on if it's right or wrong. What I would say is once you see a pattern like this, which is like minus, plus and all of this, technically this might not be the right approach to go. So what are the other patterns? The previous terms being used to calculate, right? So let's see, this 12 plus 35 is 47. Right? And what is 35 plus 47 is 82. And 82 plus 47 is 129. So obviously the next term should be sum of 129 and 82. right? That would be 130 plus 81, 211, right? That would be the answer, which is not equal to 234. So be careful on this part. So this might not really, I might see multiple levels working out if I actually see a proper consistent behavior, not like minus plus and all of those multiple changes, increasing, decreasing. I should see a consistent behavior per se. So I would generally beware of this when I see numbers like this. It's going up 23, then going down to 12, and then going up to 35, and then 47, and things like this, and minus, plus, minus. So I'll sort of stop and try for other patterns, right? The next question, find the next two terms of the given series, 32, 2, 16, 9, 8, 17. So I don't see much of a, a pattern here. Like this is 30, this is 14, this is 7, again it's going 1, so all messed up. But if we see it like an intermingled series, 32, 16, 8, 4, right? 32, 16, 8 and 4, this is one series. The other series would be 2, 9, 17, 26 and so on. So here what is this? Divided by 2, divided by 2, divided by 2. So automatically the next term would also be divided by 2. So that should be 2. Here 2 plus 7 is 9, 9 plus 8 is 17, 17 plus 9 is 26. So I am seeing plus 7 plus 8 plus 9. The next term should be plus 10, that should be 36. So what should be the term after 26? So 26 is the term of series 2. So the next term should be series 1 term, that is 2. So it should be 26 and then I should have 2 and then I should be using the series 2 term, that is 36. And these are the next two terms of the given series, right? So this is how you'll solve this when you see a series which is most probably the hint would be giving too many terms. It means it should be generally intermingled. Otherwise you will not be able to make a guess, right? You won't get an intermingled series with only 4 terms. I need to have more terms so that I can actually see 3-4 terms for each series. So that means I should be at least seeing 8 to 9 terms. So that's sort of a hint for you to see if I can actually make it an intermingled series, right? So thank you for watching this video. I hope if you're watching this in the YouTube channel, do check out our full-length courses available for free at gtcube.com/store. Also do like our partners Facebook page, facebook.com/gtcube3. You'll get a lot of updates on various courses that would help you in your preparation. So thank you for watching this video and let's meet in the next video.